Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. In modern networked environments, host services are essential for managing and supporting the daily operations of connected devices. These services include automatic IP address assignment, name resolution, print management, and centralized user authentication. Without these systems in place, managing network devices would require extensive manual configuration and constant oversight. The CompTIA A+ Core 1 exam includes questions on DHCP, DNS, network print services, and AAA systems because these functions are fundamental to the performance, scalability, and security of both small and enterprise networks. Dynamic Host Configuration Protocol, or DHCP, is responsible for assigning IP address configuration details to devices automatically. This includes the IP address itself, along with the subnet mask, default gateway, and preferred DNS server. Without DHCP, every client would need to be configured manually, a process that is prone to error and inefficiency. DHCP simplifies network management, particularly in environments where devices are frequently added or moved. It uses UDP port 67 for server-to-client messages and UDP port 68 for client-to-server communications, enabling lightweight, low-overhead interactions during configuration. The DHCP lease process follows a four-step pattern known as DORA: discover, offer, request, and acknowledge. When a device first connects to the network, it broadcasts a DHCP discover message seeking available servers. A DHCP server responds with an offer, which includes proposed configuration details. The client then sends a request to confirm its intent to use the offered address, and the server replies with an acknowledge to finalize the lease. This dynamic system allows for temporary assignments that can be renewed, reissued, or recycled based on network needs and lease duration settings. IP addresses can be assigned either statically or dynamically, and understanding the difference is vital. A static IP is manually configured on the device and typically reserved for infrastructure systems such as servers, printers, or routers. Dynamic IPs, managed by DHCP, are allocated from a predefined pool and are subject to lease expiration. Reserved addresses within a DHCP scope allow administrators to assign consistent IPs to specific devices without disabling automation. This is useful for managing known endpoints while still benefiting from centralized control. Troubleshooting DHCP issues involves recognizing symptoms such as devices receiving APIPA addresses, those starting with 169.254, which indicate that no DHCP server was reachable. Other problems include IP conflicts caused by overlapping static and dynamic configurations, lease exhaustion, or VLAN misconfiguration blocking DHCP traffic. Technicians may need to perform manual release and renew operations using commands like ipconfig/release and ipconfig/renew, or investigate DHCP relay settings on routers and switches that span multiple network segments. Domain Name System, or DNS, is another cornerstone service in networked environments. DNS translates human-friendly domain names into IP addresses that computers can use to route traffic. Without DNS, users would have to memorize numeric IP addresses for every resource, making internet navigation and internal resource access impractical. DNS servers operate in a hierarchical structure, with caching to improve performance and redundancy. The A+ exam frequently tests candidates on DNS behavior and its troubleshooting. Two types of DNS lookups are critical to understand: forward lookups and reverse lookups. A forward lookup resolves a domain name like www.example.com to an IP address. A reverse lookup does the opposite, resolving an IP address to a domain name, typically using a PTR record in a reverse DNS zone. Reverse lookups are often used in logging, security checks, and email systems. Exam questions may include scenarios involving reverse lookups, especially when interpreting NS lookup results or configuring internal DNS settings. DNS records are the building blocks of name resolution. Common types include A records for IPv4 addresses, AAA records for IPv6, CNAME for canonical name aliasing, MX for mail server direction, PTR for reverse lookups, and TXT for storing arbitrary metadata or domain validation data. Each record type serves a specific role, and misconfiguration can cause problems such as email delivery failure, unreachable websites, or incorrect IP resolution. Understanding what each record does and where it fits into the DNS hierarchy is essential for troubleshooting. DNS systems can be internal or external depending on their function. Internal DNS servers handle name resolution within a private network, such as resolving workstation hostnames, file servers, or printers. External DNS servers manage public-facing domains used to access websites or email servers. Many organizations use a split DNS approach, hosting separate records for internal and external users to isolate sensitive resources. This dual structure enhances security while supporting operational requirements and ensures internal services are not exposed unnecessarily to the Internet. Network print services allow multiple users to share access to a printer over a local network. Instead of connecting directly via USB, users send print jobs over the network to a shared printer, identified by either a hostname or an IP address. Centralizing printer access this way allows for better resource utilization, reduced equipment costs, and improved administrative oversight. Print services can be configured through operating system settings or managed by a dedicated print server that handles job queuing, permissions, and availability. There are two common printing configurations in networked environments: direct IP printing and print server-based printing. Direct IP printing involves configuring each user's device to communicate with the printer using its assigned IP address. This method is simple and often used in small offices or for dedicated printers. Alternatively, a print server acts as an intermediary, managing the print queue, providing centralized drivers, logging usage, and distributing jobs to one or more printers. Print servers allow for more control and are common in enterprise environments where audit trails and permissions are required. The print spooler is a critical part of any print system, acting as a software buffer between the user and the printer. When multiple jobs are submitted, the spooler organizes them in a print queue, allowing the printer to process one at a time. Users can pause, cancel, or reorder print jobs from this queue. If the spooler crashes or becomes unresponsive, print jobs may stall or fail entirely. Restarting the spooler service is often a first troubleshooting step when users report that printing has stopped across multiple systems. Authentication, authorization, and accounting, commonly abbreviated as AAA, are foundational concepts in secure network design. Authentication verifies a user's identity, typically using a username and password or cryptographic token. Authorization determines what resources that user can access, such as network shares, devices, or administrative tools. Accounting tracks user activity for auditing, usage metering, or compliance reporting. These three functions work together to control and monitor access within corporate networks, and are especially important in remote access and device management environments. Radius or Remote Authentication Dial-In User Service is one of the most common protocols used to implement AAA. It centralizes authentication by offloading user verification from access devices, like wireless access points or VPN concentrators, to a central server. Once credentials are validated, Radius can grant or deny access based on configured policies. It operates over UDP ports, typically 1812 for authentication and 1813 for accounting, and uses shared secrets to secure communication between the client and the server. Radius is widely used in wireless networks, ISPs, and VPN setups. TACAX Plus, developed by Cisco, is another AAA protocol often used for device management. While Radius combines authentication and authorization into a single step, TACACS Plus separates these functions, allowing for more granular access control. For example, a technician may be authenticated to log into a router but only authorized to view status information, not make configuration changes. TACACS Plus uses TCP, which allows for more reliable delivery and supports complex command-level access permissions. This makes it ideal for managing large-scale networking infrastructure. For the A+ exam, understanding the differences between Radius and TACACS Plus is essential. Radius is more commonly used across a variety of network access situations, such as authenticating users onto Wi-Fi or remote access VPNs. TACACS Plus, while more focused, excels in environments that require fine-tuned administrative control over network hardware. Exam scenarios may ask you to choose the best protocol based on whether user access or device-level control is the priority, making it important to know how each system operates and where it applies. Authentication servers often integrate with directory services such as Microsoft's Active Directory, allowing administrators to manage user credentials and group policies centrally. This integration typically uses protocols like LDAP or Kerberos to validate users attempting to access the network. LDAP allows directory queries for user and group information, while Kerberos supports secure ticket-based authentication. Together, these services enable seamless logins, single sign-on capabilities, and group-based access control, especially valuable in larger environments with hundreds or thousands of users. When troubleshooting host services, it's important to verify the availability and responsiveness of the involved servers. Tools like ipconfig can confirm whether a DHCP lease has been obtained, while NSLookup or DIG can help troubleshoot DNS resolution problems. Connectivity testing via ping can determine whether a client can reach critical services, and checking server logs or restarting services may resolve stalled or misconfigured systems. In some cases, manually reconfiguring client settings or clearing caches can restore normal operation. In conclusion, host services such as DHCP, DNS, network printing, and AAA form the operational backbone of nearly every business or enterprise network. They ensure devices receive the correct configuration, users can locate resources, print services are shared efficiently, and access is tightly controlled and monitored. A technician certified in A+ is expected to understand not just what each service does, but how to configure, monitor, and troubleshoot these services in real-world environments. Mastery of these concepts is critical for supporting scalable, secure, and reliable network operations. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.